So what's important, I mean, if I can give any advice on this, is to be very realistic about what you do with your stuff. There is no value to put things into some Kafka topic, which is broken messages, right? What do you do with that?
Yeah.
So you need to understand how do you resolve them, what's your thresholds, when you need to start be worried about.
Hey, this is Vitaly from Map for Engineers, and today we have episode 6 with Dmytro Hnatiuk, who is principal engineer at Wise. I used to work with Dmytro a little bit in Wise. We were in different teams, but I got to know him as a person, and I had a pleasure to have a chat with him this time. And our topic is around scaling journey of finance engineering in Wise and how Dmytro played a pivotal leading role there. So I hope you enjoy, and thanks for listening to the podcast. So, Dmytro, welcome to Map for Engineers.
Thanks. Thank you for having me.
Yeah, and maybe we can start by introducing maybe each other even to the audience. So maybe some don't know, but we used to work together a little bit, right? In different teams, and then I moved to Starship, but you continued. And but maybe you can tell us, your journey in Wise, how you started, what are you doing now, and maybe a bit of background.
Yeah. You moved away, but I'm still in Wise. But my name is Dmytro, and I've been a software engineer for not too long, but maybe more than 10 years. And I joined Wise like 8 years ago. Wasn't the first place where I worked, but it was a very reasonable place where I worked.
Before you worked in Ukraine?
Yeah, worked in Ukraine. I've gone not really the classical path for the engineer from Ukraine, but I used to work in consultancy as well, and I had the pleasure to work in a very tiny, like three software engineers company, which was a very distinct experience. And then at some point in time, I was invited to join Wise, move to Estonia. It wasn't really the plan to move to Estonia, but I knew very little about Estonia before we moved. But then I started to learn more and more about Estonia when I started speaking with Wise recruiters. Got quite interested, and that's how we ended up in Estonia and here for already 8 years.
Can you tell us about your journey in Wise?
Yeah, no, Wise is an interesting journey. I think when I speak to some of my colleagues, someone might say that in Wise 1 year counts like 2 or 3. So for my 8 years in Wise, it's quite a long time, kind of.
And company changed quite a bit, right?
Yeah, changed a lot. It's very different companies. It's not even one company and then the other company. It's many different companies in the meanwhile, to get to the place where you are right now. And so I joined Wise as a engineer. I joined what used to be a verification team those days. Mostly was about customer due diligence, and Wise at that day was maybe 400 people total, and a much smaller engineering team. And I joined as an engineer and joined verification team. It wasn't really the choice where I will go. I was kind of like allocated to verification team since they needed kind of someone to help them. And it didn't take me long to understand that it's not really the kind of domain where I'm very keen to be in. I was always quite interested in knowing more about financial systems, about economics, and this kind of things. In fact, I was in my school years, I was thinking to go to finance degree.
Oh, okay. Yeah. But you studied computer science, or?
No, not at all. Yeah. So I was thinking to go to finance degree, but then I realized that there is apparently no option for me to go for like government-provided education for the finance degree, and like I needed to make a choice. So where do I go? It was very funny because my mom suggested me maybe you should go to learn computer science, and my response to that was that I don't really see myself staring into a screen for whole days, you know. And I said that I want to do something where I will be like outside, I will work with people. I want to do engineering. I was interested in engineering. I decided to go for mechanical engineering. Yeah, I mean, like it's a separate story, but ended up being a computer science, like a software engineer. So and back to verification stuff. So I realized that this verification, customer due diligence, is not really the area I'm particularly interested in, and I want to understand how WISE works in terms of its core values. Why customers would use WISE. I want to understand the system from inside. Like what's the bread and butter, so to say, of WISE. So I had the choice, where do I go? Do I go to some sort of payment processing team or to finance, treasury? You know, I was only considering really some platform teams. And yeah, and I made my choice to go to the place where I felt would be most broken. So this is how I ended up to join WISE finance team. And so since then, it's already like 7 years. I've been mostly in this finance, and now I'm more in
7 years.
treasury domain. Yeah, so I moved from verification after 1.5 years roughly of being there.
I just want to, maybe it's a bit of trivia to mention, but I remember I was shortly in AML team after global partnerships. I moved to AML, and I remember we were in our corner. There was verification team and AML sitting quite together. And some guys were discussing something related to Hibernate, maybe some specific details like, hey guys, how do transactions exactly work and how do we manage it in Hibernate? And Hibernate is quite complex and you have to understand it. I mean, it's complex, especially if you don't know about it or you have not read internals or how it works. And then you were like, actually, you know, this works exactly like that. And yeah, you know, it's by the way written in this book. And yeah, I kind of remember that comment very well because I realized, yeah, you pay attention to details and you like to dig deeper into things. So if I remember correctly, you read some Hibernate book or something.
Yeah.
Because I remember that comment like yesterday.
Yeah, it's kind of very close to to my nature. So when I would want to know about something, I would want to know it into very level of details. And this is sort of kind of illustrates the way how my journey in software engineering was in general. So when I started learning kind of computer science and software engineering stuff, I've been doing this by myself, and you know that days the approach to learning was very different than today. I feel like today learning computer science or software engineering is at least 10 times easier than it used to be. Especially if you are not in a degree of computer science, if you're not being taught for computer science, because I was learning myself, so kind of you need to scramble and find the right things to study stuff. And I started with .NET framework, and it was about so I learned Visual Basic, I learned C#, and I was one of the best books that I ever read was about CLR, compiler intermediate language for .NET. Yeah, and it was a book from Richter, and it's basically like almost assembler code, but for .NET, you know, like Java bytecode kind of stuff. And it was like so interesting. I was very much in love with, you know, knowing the internals, how exactly it works. It was kind of a lot of fun for me. And I do recall the case where I was invited to give like lectures, like teach people for programming. And my part was in the very end of the course. So that was like maybe a couple months course, and people been green, started learning programming. And I was like so passionate about the memory management, about internals of .NET, and my lessons obviously been like to the end of the course. And I remember like very clearly where I come to the lesson, and I talk in that level of details about how things work. And people just a couple months ago started learning programming, and I remembered like them feeling so kind of lost in some sense, but kind of importance of that is that if you're that kind of person who is interested in the level of details, then this might sparkle some kind of passion in you, and you might kind of go deeper on yourself as well. So that's kind of, and this is basically back to this Hibernate thing. It's the same stuff there. I was new to Hibernate, and I started learning it in details, and there's a brilliant book about high-performance Hibernate, which is, high-performance GPA. Less about Hibernate. It teach you a lot about the databases as well, transaction management, and that kind of stuff.
Yeah, I think just maybe what lesson I could drive out of it, and I completely agree with you, is that focus on fundamentals is important. You cannot build on higher level of abstractions or be effective in it if you skipped on understanding the fundamentals. Like, I've had cases where I interviewed people who want to be big architects, software architects, but they did not understand how arrays work, like literally. Not arrays, not even like simple data structures. And they didn't understand how CPUs work, RAM, those things, and arrays on top of it. And that's a problem, actually. They didn't understand how database indexes even work, or even conceptually. I didn't ask them to explain me the B tree, right? I just asked, like, how do you understand how indexes work? And they could not even tell that. And that's a problem, right? So and that's not saying that you should become an expert in like low level, be an expert in assembler, etc. But to understand conceptually a certain level is important.
Yeah, I agree with you. It's you build your architecture and make your decision based on the understanding how system works. And I mean, I agree with you. It's not that you should understand very well like processor cache to build your Spring Boot microservice, but still it's kind of good to understand the concept. And what I find the use of it is that you might not necessarily need to apply those things in practice because you know them, but because you can draw the parallels to your immediate problems that you work on these days. Like, there's a benefit of knowing about TCP protocol, how it works, because you can understand it, like handshakes, all that kind of stuff, which you can then apply in your future job. And if you understand it well enough, then you can understand the meaning of it and apply it to some different situation where it's just as well as appropriate.
Yeah. Another example would be, and again, we'll move on to another topic, but just to bring another example is, I mean, in engineering, sometimes it's actually critical to understand the importance between concurrency and parallelism. You can build a concurrent model which runs on one CPU, but it's still critical that you have this concurrency model, but it might not run in parallel, right? But understand too, like, what actually means parallelism, what means concurrency. Well, in some cases will be important if you deal with these cases at least, or how it runs. Do you want to switch gears and talk about or continue talking about the finance team and the journey there?
Yeah, it's quite a journey actually. As I said, I joined finance because I felt it was the most broken thing I can work on.
Broken in the sense that there were very little kind of software engineering related processes. There were many manual processes, right, at the time.
The kind of the setup there is different things are different on different stages of your life cycle of the company. And in earlier times, in Wise was way more important to grow, to get to new places, get the coverage. While financial reporting, although more or less understood being important thing, was not the very focused area for software engineers in the company.
Got it.
And at some point in time, we got a very strong kind of technically, financially, from like legal perspective person who built a lot of things in finance, built very quickly, extremely efficient, and it was solving the problem. But over time, the understanding came that you should apply the same standard engineering principles to what you do in your product organization as well as what you do in your finance organization.
To scale.
To scale, yes. To scale, to make sure that you scale not just in terms of technical scalability, but in terms of people who you can onboard to it, who can work on your problems, engineers who can contribute to the same code base, and that same standard engineering principles, they were not there when I joined finance. So at that time, we as a Wise, we been very used to Spring Boot service microservices, but in finance, for example, for you to deploy the software, you need to do kind of SCP to machine. You build your jar file, you put it in the right folder, you write the Java, in a shell.
So there was no
So
continuous integration pipeline.
No, it wasn't at all.
No tests probably running as well.
No test at all. And it was like 1,000 line Java methods, which you've been doing, everything that you can do,
and
possibly do.
Just to give perspective to the audience, I believe Wise was already a unicorn at the time when all these things happened.
Yeah.
Right? But this is just to show, and I don't want the audience to think that all of the Wise like that. Actually, it's on the contrary. A lot of services in Wise were written using best practices, TDD, tests for everything, very rigid pipeline with all levels of tests executing because, well, there were like critical services. You move money from A to B. So it was very serious. But yes, in this particular case, what you're saying is that these practices were not followed, but it was sort of a conscious decision. And then it was a conscious technical debt, and now you realized, okay, now it's time to pay it back.
Yeah. It was very well understood that you need to apply the same standard as you have in Wise to the finance team as well, and this is where I felt I can contribute. This is where I seen this opportunity to bring in the expertise from other teams in Wise to finance, and I joined the team, and as I said, there was brilliant people in finance, and some are still in finance to those days. And everyone was on the same page, understanding the importance of what we are doing. And it was actually acknowledged on the company level as well. Because actually who brought me into finance was Bogdan Dmytro Hnatiuk, who was the first engineer in Wise, and he himself was working on finance at those days, because it was understood that this is an important thing to get done right. So I joined finance as an engineer. It was 3 or 4 people, like engineering team on those days, but I was very happy to have a chance to work with Bogdan, to learn from him. But then half year later, Bogdan said, Bogdan went away. He said, like, okay, Dmytro, now you take care of finance. I'll move forward.
It reminds me like this scene from Panda Kung Fu, where this master of Panda, he dies or whatever, but he's like, and Panda is like, oh no, you're going away, so he left you on your own.
Yeah, exactly. It was kind of unfortunate in some sense, but I'm very lucky for having the opportunity to work with Bogdan further on, because even though he haven't been a part of the finance team, he still was my lead. And basically I become a lead of finance engineering team.
So that was the moment when you switched from software engineering to the lead.
Yeah, to the lead, and that was. I wouldn't say it was a very intentional move to do less of IC, individual contributor work, to move to people management or that sort of things, was kind of, as I said, was not intentional. It's reflecting a bit on that move. It was because I cared a lot about things. I was deeply passionate about what I was doing, and that's why there was no kind of better candidate to take a lead for the finance engineering team.
Sometimes I think that the best managers are those who do not want to become managers.
Might be.
Sometimes.
I'm very up to people to make the very thoughtful and conscious decisions. In this instance, where I started to be the lead of the team, it was not that of the conscious decision. But to be fair, it didn't change a whole lot back then.
You were still doing design, software engineering
very
design,
much.
and coding and everything.
I was still coding very actively, and we had a very small team with really high dynamics. So it just was a bit of other things that I needed to take care of. But other than that, I wouldn't say that changed a whole lot for me. Over time, obviously, it started changing as we started growing the team larger. So we first been 3 or 4 engineers, and then we got slightly larger. And then we understood that there are certain domains in finance that need to be split farther on. So we grew first to be a squad of 2 teams, I believe, and then there was a third team introduced. So we understood that there is more customer-facing parts of finance, and then there is more internal things about finance, and then there's a control area. So we started kind of being more mindful about domains that we operate. And as this normally happened, you just realize that there's too many people on the stand-up, there's too much of context for them to comprehend, and you realize that this is a time for move on and introduce the other teams.
Can I ask on this, because I think it's an interesting topic, on this team split? So you were growing at some point, then you realized, there's customer-facing finance and internal finance. You decided to split, and you mentioned the interesting word called squad. Can you explain to the audience what squad means in WISE, and how these then 2 teams interact with each other? Because as I understand, there was some interaction points. And how did you relate in the squad?
Yeah. Now, actually, was a lot of evolution about how do we think about tribes and squads and teams in WISE. I think maybe teams been a bit more stable, but in terms of squads, so we kind of see that as a unit with very similar goals, connected organizationally to the squad, with a more closer leadership overseeing for the specific number of teams.
So you were the lead of the squad?
Yeah. So that's kind of also went very organically, because I was leading the finance team, which then grew to be bigger, and there was a decision to make it into the sub-teams.
So squad is like the umbrella of few teams, very kind of almost like coupled or connected. And does it mean also, just curious, when you do plannings, or of course stand-ups are separate, I assume, and maybe even retros are separate? I'm not. Did you have squad retros? Just curious.
No squad retro.
Okay, so still team. What were the common things you usually did on a squad level? Just curious.
So there was actually the planning's been very specific. Planning's been mostly a team driven. What was important for me as a squad lead is to oversee the goals of the teams and make sure that they are connected to the goals and intents of the tribe and the company.
And what is tribe in WISE terms, so that audience
so
also
it's just
understands?
a more broader set of teams and
set of squads, right, or teams?
Squads.
Kind of.
It's so now in WISE, there was a lot of evolution really, but we kind of have finance, treasury, pricing sitting under the same tribe. Yeah, since we are kind of connected in that terms where you're doing the financials, where you're doing the FX risk management, treasury management, pricing, this kind of stuff.
And there was tribe lead, then squad lead, and then teams. Yeah, I just think it's very interesting for listeners because, I mean, it's not in every company like that, right? And it's I guess the company at some point reaches some level where they are rethinking, okay, how do we organize, how do we scale in terms of, because, right, there is sometimes too much overhead in terms of organizational structures, but sometimes there is a necessary overhead or structure you need to create to kind of keep evolving, right?
Yeah.
Because you cannot keep evolving like to, 1,000 employees if you just keep team level, right? So in Wise it's teams, then squad is an umbrella over team, and then the tribe is umbrella of squads. And tribe has some, like, again, general topic or theme, right? And then squad narrows down and team narrows down even more.
Yeah. It's I'm very happy that I haven't seen too much of this in Wise, but I feel in other places leads have wrong intentions behind creating the teams, kind of working for hierarchy, trying to introduce teams, introduce squads.
It should be a last resort, right?
Yeah.
Almost.
Yeah. I mean, the goal there is a bit of the kind of, there is a flaw, right? Where you want to have more teams, you want to have more kind of reports, more hierarchies, where you kind of get to be the manager of the manager, this kind of stuff. And although that might sound like a comic and...
But it's true.
Yeah, but it's true. It's just kind of what's happening often.
Yeah, and some are professionals in doing that, like in creating these hierarchies.
Exactly, and then you see the team with one person, and then there is a lead of that team, and then there is lead of this team. It just sometimes makes very little sense. So far, I'm happy to see that I have not observed many instances of this in Wise, especially in engineering, but not very pragmatic about splitting to teams and not creating that overhead of organizational and then administrative burden of that management of stuff.
Can we talk? I just want to make I want definitely you to delve deeper into actually software engineering in the finance and all of that, but to touch kind of as a gradient topic between the two. I want to discuss the Conway law with you and how the team splits and communication within the teams, even in your squad, affected the evolution of services or like the technical mirror of that in terms of repository services. And just for maybe the listeners, and I hope it's okay that I mention it, right? Wise started as a monolith, right? A long time ago, and it's been a monolith since until it became a unicorn. Actually, I remember when I joined Wise in 2015, maybe it was a long time ago, summer 2015. It was still a monolith. Maybe there were a couple of few services here and there, but mostly it was a monolith, and it was exactly the time when actually we started to have scalability issues, and we were like, okay, let's actually start splitting things. But why I'm mentioning it, so it was a monolith, then you started to split services. How this structure of architecture and services and repositories looked like for finance team as it was growing relative to this team reorgs and team growth?
Yeah, no, it's a very important topic. I need to acknowledge that sometimes you would have this unintentional side effect of splitting into teams where you would have the technical architecture start complying to your team setup, where you would have a team who will be very locked into what they own, and they would obviously they don't interact so much with other teams outside. And here's the role of squad lead as well, to make sure that there is a right overseeing of this, that people do find this connection where they understand that there's no point in creating two separate services which are doing the same thing if you can kind of join up on doing the single thing as a squad, really, or as a tribe, or it's really like as an organization as a whole. So for us, we had the single microservice. but then we also had a single database, and we started modularizing in terms of services. So we kind of so it worked this way, that we understood that there is a specific domain that we need to split, for which we introduced the service.
Service. When you say the word service, you mean
like microservice.
Microservice, internal.
Yeah,
Okay,
yeah,
not the service layer inside.
No,
okay,
more like a
microservice.
microservice, and
yeah, separate service with its own separate repository.
yeah, and a separate database. I would say the finance function never really was a part of that monolith. I mean, it was, but it was like in the very early days, and somewhere even before 2016, that all kind of wrapped up, because it was understood that there's just no ability to do financial reporting in the right way if you're still the part of that common shared thing. So for us in finance, we started as a microservice with own database. I mean, they all started with those Java files, jar files that you deploy to your machine directly, but the next iteration, which come quite fast, is the microservice. And there was a lot of work to move this Java kind of 1,000 lines classes into the actual microservice with a more proper technical standards to it. So we collaborated mostly on the single microservice and the single database, and then we understood that there's some domains that we would benefit from separating and evolving. So we moved this out as a separate microservices, and for quite a bit of time the database was a multi-tenant setup. So we had some microservices, they work with the same database, but kind of I see that often modularization of services is faster than modularization of data. But then modularization of data is equally, if not more important than modularization of the actual microservices.
Yeah.
And then yes, we understood there's domain. We divided the microservice with a shared database, but then the data modularization projects, they came after. So we kind of at the moment finance operates in the setup where there's still some multi-tenancy in the database, yes, but quite some microservices that they have their own databases, obviously their own repositories. This is kind of a very standard pattern for device as a whole.
And they communicate with each other through events, right?
Yeah.
Kafka or some API calls probably here and there, depending on use cases.
So we do prefer the event-driven communication, unless it's mandated and strictly necessary. Generally, I'm big advocate for the event-driven communication. It might be a bit harder to make it work in the right way, but it really pays off in the long run. I sometimes hear people complaining about microservices, that it introduces complexity, but then when digging a bit deeper, I come to understand that their complexity and the issues of reliability, they are very much related to amount of the HTTP calls they do.
Yeah, so a communication between services matters a lot, right? It's pretty much, I mean, it's everything.
Yeah, exactly.
And if you get it wrong, then, well...
Yeah, and if you have 1,000 microservices and you have only HTTP communication between them, then it's just nothing else than monolith.
Yes. Because again, I mean, you also inherently couple the caller, I mean, yourself and the other service, instead of a more inherently decoupled architecture where publisher does not know anything about subscribers, right?
Yeah.
Cool. So what's next? Let's say you, it was good detour. So you kind of split. But yeah, I'll actually let you hear because, well, I don't know on the specific topics, let's say, that are very interesting to highlight, and especially on this journey of scaling finance. So feel free to go where you want from here.
No, I think it's also important to bring in a bit of the context of what finance is doing, what finance is about,
Yes.
actually.
Yes.
Because it's, to me, spending so many years in the finance, it
It's
feels
obvious.
all like obvious and very natural,
Yes.
but there is different ways how companies do financials. And that border between what companies are doing in terms of their main product and how they do financial reporting and accounting, all these kind of things, it's often being very hard line. So many engineering teams, they would not be aware about how this is being done, how the financial reporting being created, what it is for. I'm happy to see that change a lot in Wise. It was a lot of hard work to make the finance less transparent to other teams. I mean, for the good and for the bad reasons.
To make it more transparent. Right?
More transparent, yes, to kind of bring in this awareness of what finance is for and why this is important for us as a company to do the financial reporting. And some companies, they are very classical batch approach to do the financials. So you will have some data warehouse, you will have some data lake, and then once per month you will run some very large batch scripts aggregating tons of data and then producing your end financial or reg reports, this kind of stuff. This is absolutely not the way how finance work in Wise. So we in Wise, we build the finances really as the same engineering standard as other microservices, as other teams. We are very event-driven communication. So, and we kind of Wise is in almost one of not many unique places where we have real-time financials
in the world.
In the world, yes, and in the industry as well. So it's in some sense it's driven by the fact that we are a financial company and we are specifically regulated, and there is inherently much different standards and expectations to us as a financial company. But also because we are following the same engineering practices, it was very natural for us to build the real-time financials, which are then beneficial in many senses. And this is kind of hard technical problem to solve as well. So we started, so in 2016, for example, the database that we operated with its main general ledger, like a main accounting book of Wise, it was 60 million records in it.
60 million.
60 million, yeah, per year. Per year, yeah. But now we have more than 24 billion records in that single table in the database.
Wow.
And that's per year, so it's growing a lot.
24 billion records. What's the rate per minute?
It will be averaging out to maybe. So if you think about what we are doing in finance, so we are consuming data from other teams to then later form it into the financial and regulatory reports to the main accounting book of Wise. So we would consume these external events from other product teams who will share with us them through Kafka, and then we'll do our finance magic. So if we measure the throughput on the input into finance, that will be maybe from 50 to 70,000 events per minute.
No.
And that's not insanely huge, but it make it very tricky if you think about this from perspective of financial reporting and compliance. So there is no opportunity for you to miss data. There is no opportunity for you to do it wrong. And this is there was a lot of efforts spent to make sure that you can keep on processing all this data inflow. You do it very transactionally. You do it with a very high level of confidence in what you're doing in terms of controls, error handling, all this dead letter queuing, all these things become very relevant. So this is what makes actually finance in Wise being very interesting. It's one of not many places where you deal with that volumes of data. So we would consume up to 100 different Kafka topics to do our accounting. So it's an insane amount of complexity.
Can I ask on this dead letter queue? Because I know it's a tricky topic. It's tricky in a sense not to create a dead letter queue, but to build a process around it.
Yes, absolutely.
And this, I mean, I had to deal with this kind of questions in every company I was, in a sense that, oh yeah, let's have dead letter queue. Okay, so what shall we do if the message gets there? We're not sure. We actually need to discuss that. So could you actually let us in a little bit, whatever you can share, in how you handle dead letter queue? Because that's a very interesting topic. Yeah.
I think we kind of found the way how do we deal with this. I would say it's very mature by this point.
Mature.
So yes, yeah. So we do have very good observability around how much events being broken, what type of failures do those events have. Like if you do have different from different topics, you receive different sort of event, but if they will fail with the same sort of problem under the hood, because there might be some kind of synchronization points between those events, then you will have this observability around them failing because of the same reason. You will have them grouped, you will understand how many of them, till the extent that you will also understand what's the monetary impact of that failed event. You have the escalation process, how do people react on this, and you have a playbook, what they do if they, if this thing happen. And there is the threshold, alerting, all this kind of stuff. We've done a very long path to get there. And
can I ask actually a few questions on that? Because every word you mentioned is super important and interesting. Observability. I mean, my first, I guess, if I was building things from scratch, I was like, well, I might add observability, I don't know, using in Grafana, for example. But I'm just curious, do you use some, some existing tools in the industry like Grafana to visualize it and, I don't know, under the hood, maybe Prometheus or something? Or do you use something ad hoc, bespoke?
There's different levels of observability. So we, so the first kind of level of defense is what you're describing. So we have Prometheus, and then the metrics being visualized to Grafana. Then we do have the second level of defense, where we go into more details in terms of analytics around those failures. So I'll just give you a very specific example. If customer is doing transaction from one currency to another, to sending money to someone else, so we in finance will have the same level of granularity. We will understand that the customer is doing this transaction. And if there's any technical error or any business-related error, then we have the post-processing, which is kind of...
It's business logic itself.
Yeah, it's a business logic, which will be understanding what sort of error happened, how long this error is there, who need to look into it, and then like what impact it has in our financial reporting. So we have a custom-built user interfaces where you see all financial situation of Wise with a very fine level of details. If
and
you
the
want to
errors will
drill
also
down.
be there, like some specific things.
So you will see that you have the whole balance sheet of Wise financial statement sort of. And then you can, from that very high level, you can drill down to this individual transaction and understand who is responsible for fixing it. Because we have this classification process down the line, which is understanding exactly who is responsible for this error to happen.
Cool. And maybe if I may, I'll make a conclusion and you tell me if that's right or wrong. When, let's say for listeners, I mean, every company will be different and the handling of this dead letter queue will be very specific or of errors. But I would say one of the most important thing is to map out business processes, like what do you want to do with your errors, and be as realistic as possible. Like, who owns which part of the error? Is it the error because of the bad request on the who published the message, or is it something in your service? Is it only that the engineers are involved, or is it operations? And if it's operations, can we natively support so that the escalation will happen to operations right away without engineers being involved, right? And all of this is very important for engineers, and this is maybe talking already about product engineering, why this is so important to understand the problem end to end, and not just like, oh, this is dead letter Q, let me focus on dead letter Q. Dead letter Q is just the means to an end, right? And the end is to solve a problem, and sometimes you need to like end-to-end understand the whole thing. But that's my
100%. I fully agree with this. So what's important, I mean, if I can give any advice on this, is to be very realistic about what you do with your stuff. There is no value to put things into some Kafka topic, which is broken messages, right? What do you do with that? So you need to understand how do you resolve them, what's your thresholds, when you need to start be worried about, and be realistic with your capabilities. Because I found that in finance, we sometimes been over harsh to ourselves. So we try to kind of get every problem, regardless of how big is it, to kind of get it fixed, which is really put a lot of strain and burden on the people. So it's just kind of be very pragmatic is important here. Sometimes you just might not have this opportunity to get every problem fixed. And I mean, to me, like that comes kind of very naturally, is that we do have what you're describing, where there's a business process, there's an analyst involved who might be responsible for this. There might be product people who are causing this error to happen. So there's kind of different levels of escalation as well there.
Yeah, that's, by the way, what we started to notice in Pactum. If I talk about Pactum, is that, you know, right now for error management we use Sentry, and all of these errors are viewed by engineers, and they need engineering attention. But then you start to realize, wait, not all class of errors have to be dealt by engineers, because some are even created because of some misconfigurations by operations, and even operations themselves can fix them.
Yeah, exactly.
And now we are starting to think, wait, we need to natively start to differentiate those things maybe. And like the full disclosure, we haven't yet like implemented like very robust system for that, but let's say the plan is to move into that direction, exactly, because, well, we started to see the bottlenecks there.
Now this is like, those things that you're talking about, they are very applicable to almost any problem set. And being in finance, been very passionate about controls, reconciliation, and kind of quality of stuff.
Right, but if we continue on this real-time financials topic, so you mentioned kind of, you gave the overview of what was in 2016, so ledger of 16 million records per year, and then, well, now 24 billion records per year, right? What else would you like to mention in this, or go into which topic related to the, well, scaling journey in finance engineering?
No, it's. I recently spoke on a conference, and the topic of my presentation was how not to become the database expert. And kind of my learnings from the scaling journey was that you need to make the right decision in the right time with your optimization and with your scalability. And what do I mean by that is there is no value from you to fine-tuning some very minuscule details of your system if there is no value from it. So it's very important, if you're embarking into the long journey, to understand what do you do when, and be very conscious about this.
And part of that is defining the exact problem what you're solving.
Yeah, exactly.
Right?
The kind of what you're working on and why this is important. Because unless you're really clear about this, it's you know, what you're saying about product engineering, then there's very little value from you to be an expert in some specific technology set. And our journey in finance was very natural in that sense as well, that we grew like separate domains, and we by technically separating the services, it let us to scale them differently to what they need to comply. Like if you have the real-time ledger, so things being displayed there real time as they happen in Wise, that might not be the case for other parts of the system who are doing something daily or monthly, for example. So this is why it's very kind of crucial to be able to focus on the right things.
What would you say have been the hardest challenges or problems in this whole scaling journey so far that are worth sharing, in your opinion?
Well, there's definitely technical problems which are hard. And then there's organizational things. And kind of, I think the biggest problem always is to build the right team. So kind of get the right people to solve your problems.
And it's also about getting people with the right set of mindset, values, and principles, right?
Yeah, exactly. Because so in some point in time, there was a setup where in my squad, kind of everyone except of one person been interviewed and hired by me. And you feel very personal and responsible for the outputs that those people make. And not always you make the right decision about getting on board the right people. So for me, those kind of building the right team with the right people, with the right mindset was one of the hardest problem. And kind of culturally as well, it's no value to bring the brilliant software engineers, brilliant in terms of technical knowledge, if they cannot perform as a team players.
As team players, yeah.
Yeah, and there have been some instances like this, and it's always kind of very hard. And I think if you get the right team with the right people, with the right intentions, then solving your technical problems, I mean, it's a doable thing.
Yeah.
And yes, for us, then the next part is the technical problems, obviously, and seeing that growth in like 250 times in size and in volumes of the data that we process, it's been challenging sometimes, and you needed to become very kind of expert in what you're doing in terms of the even technical decision making, which is it's not always intentional, but you just don't have other way unless you go into internals and understand why the things doesn't perform the way you want them to perform.
What set of skills would you say that you had to hone and become very good at, and your team, of course, to solve the kind of problems that arise with scalability challenges? Like what, maybe you can share with listeners, what set of skills were super important, and could be like, again, hardcore skills about some technology or database or software design. So
Also, software design is obviously very important for the team as a whole. It might not be crucially important for one specific individual, but for the team as a whole to have this expertise and be able to make the right decision, it's very important. But in terms of hard skills, there's a database was like really our bread and butter, because when you operate a 30 terabyte database with kind of 15 or 20,000 transactions happening per second.
You used Postgres or
Postgres, yeah.
Okay, and you were vertically scaling it, or how did you, or you had shards at some point?
So we've been doing no shards. We haven't been doing shards, but we vertically scaled that, and we also modularizing it. So then you don't have all your eggs in the same basket.
Can you elaborate on modularizing database? What does it mean actually? Like, you mean by tables and schemas, or you mean some
it's all kind of domain driven. So you understand that this set of problems are the part of some specific domain. Like, for example, when we started being more conscious about controls and quality of the financial reports that we do, so we understood that there is a domain of quality controls and financial assurance. Then we separated them, the microservices. We also then understood that these microservices, they are dealing mostly with this set of data, which we then modularized out from the database into separate database. So that's kind of natural modularization process.
That's a very good point, right? Because when you, let's say, start to see some separate bounded context, you have to apply this modularization on all levels, right? From software and all the dependencies of packages to each other, down to data model, and making sure, okay, now you actually want to have separate schema and the data model, because then, but what's cool about it is that you can start this modularization process, and maybe not even you can, but maybe you should start modularization process, as Sam Newman also tells in his books about separating to microservices, inside the service itself, if you want to separate it out. And once you have all the pieces separate, well, then you literally just technically move it to another place. Okay, so yeah, just wanted to clarify. This is what you meant by modularizing.
I agree, and the same about database. So we made the decision to have the separate database schemas, which I mean very applicable to Postgres. Some database would have a different way, but we got the different schemas for different domains, and then modularization of that data out from database was quite straightforward because you understand that this is the separate schemas.
Yes.
You identify if there's any cross schema joins.
Yes.
If not,
and it's very easy to identify it.
So then you kind of move that out.
Yeah, we, by the way, in one case use the same approach in Pacton. We have one service where domain is evolving kind of rapidly, dynamically, but we are not yet sure, do we want to separate one subdomain into separate service or not? But what happened is that this subdomain, let's say, or kind of maybe separate bundle context, it has some shared kernel in the code, like common things, but it has its own schema. And it's kind of helping it because we know that, well, when we will want to move, kind of at least from the data model perspective, like we already are making our lives easier and we are not like coupling to on that level if we don't need to. And then, you can kind of naturally move out or...
Yeah, it's just that it requires a lot of like a stewardship and discipline to make sure you do not create this interdependency. Otherwise, you might find yourself in a very dangerous place where you technically have separate schemas, separate data models, but then they are being constantly joined with each other.
Yes, yeah. I would say, if maybe let's analyze it a little bit. So the couplings, like when you separate, you need to analyze the couplings on all levels, right?
Yeah.
Like starting from, I mean, apparently from how these two services currently interact with each other. Is it that, do they have well-defined interface? Is it RPC calls, or inside the service, what are actual package dependencies? Do they have some common shared kernel or not? And what happens in the database? And so you cannot just normally look at like, I guess my point is you need to do a careful analysis of couplings before you kind of, or when you consider to separate.
Yeah, 100%.
Cool. Any other, so you mentioned about expertise, that you had to become experts in database.
Yeah.
Can you share some stories like what you actually had to dive into to become good at with databases?
Yeah, I mean, my full journey in Wise is that I used to be the squad lead, but then at a certain point in time, I don't even remember, maybe 2 years ago, I kind of understood that I would bring more value if I would be more in the shoes of the individual contributor, like being more like technical lead rather than people lead.
You switched back, in some
sense,
or switched forward, should I say?
Like back, yeah. So I moved from being the engineering lead to being the individual contributor, like a staff engineer role.
And if I may say, you are now principal engineer, and there are like what, 5 principal engineers in Wise?
I think 4.
4. And how many total engineers? Total amount of engineers?
900, I guess.
900.
Yeah.
Well, congratulations on this role. Yeah. Can you a little detour? What are responsibilities of principal engineer in Wise? And I know it's a super high level question, but
I kind of, when you're seeing this journey from someone who just started in the software engineering career to more like a staff plus levels, the higher you move, the less clear what people need to do.
Yes.
And this is what actually I see happening in Wise is kind of giving you very abstract answers about impact, right? And for different principal engineers and staff engineers, for everyone pretty much, that impact is realized in a different way. So someone will be very brilliant in building the libraries, which will be used by other teams to solve their problems. Someone, which I feel it's a bit about myself, will understand very well about the problems, like business problems that we solve, and being able to connect it back to the technical solutions that we apply to solve them. That I think is one of the strengths that I have. I never said that I'm a best Java engineers. I'm quite good in databases, but not like best Java engineer who is like
But you can
extremely
find
good.
very good business
Yeah.
problems and then
Yeah.
go back and implement very decent technical solution, let's say, in the team.
Yeah, that's
And,
that's where I'm kind of mostly sit with. This kind of joining the product vision to the technical implementation is something where I've been spending most of my time.
I think you said very wise words, yes, that wise trademark. Why should trademark the word wise? The word wise. Yeah, but you said very wise words, and you said that the more you grow, the less kind of clear it is what you need to do, and this what you need to do. It's almost by design that it is not clear because it's up to you already to produce this vision and to leverage your strengths. And people give you this role because they saw that you can manage yourself and you can solve hard problems and find what's important is you can find correct and good business impactful problems to work on, right? So you're not given them, but you find them. And this is really hard. And it's very ambiguous by design almost. Like, what do you solve next?
Yeah, that's kind of, I can quote the words of my current lead, who said very correct thing is that you should not seek for immediate reward in what you're doing. Rather, you should deeply care about what you're doing and make your best in terms of do it. And then that the reward, it will come, in the form of promotion, whatever, it will come as a kind of side effect of you doing the things that make most sense and bring the most value.
So living by the truth and finding the truth.
Kind of, very, I mean, in a philosophical sense, yes. And
because it's easy to lie to yourself, right? What you mentioned with those middle managers who are very good at, I mean, not talking about all middle managers, but let's say those in some companies who are very good at creating hierarchies. This is kind of the opposite of living by the truth because you're deliberately not trying to create the value, but you're just creating some structures for your own benefit, maybe. But here is vice versa. You try to kind of remove all that noise and try to really focus and ask yourself, what's the value I can produce and what's the most impactful thing?
Yeah, and then for me it was this decision that the most value for me is to work more with the technical concerns rather than with people concerns. I mean, obviously, by being staff plus level, you would anyway work both with people and with the systems, and you need to be reasonably good in, communicating with people and finding your way to different people to kind of solve the problem. Because in the end, it's less about, it's always about people as well. Who cares about this problem? Why do you need to care about it as well? And how to solve it together with those people.
You mentioned about caring about the problem. May I ask you about this one thing? And you touched it from another angle. Is one of the hard things was to hire correct people and build a good team. This was a hard challenge. Can you share what, or maybe personally even, what are your principles and values and mindset that you follow in this finance engineering domain and finance teams or squad that you feel are very important to succeed in this role? And
it's part of my values is really care about what you're doing. So that's what I seek into people, that they care about what they're doing. They engaged with a problem that they need to solve, and they at least try to solve it to the best of their ability. Wise has a great values, and then everyone do interpretation of them in their own way. But this is what important for me is to kind of transparency, being honest with with the people you work with, and not try to fool them, because in the end we all are smart people, and it's when someone is being non-transparent, that's very visible and very distracting to people.
And this can get down to very simple things, like, for example, right, when someone doesn't feel good, instead of lying and saying some things and making up some reasons, just say, hey guys, I don't feel good today. I actually feel like taking the day off. I mean, maybe
yeah,
that's
it's a simple
one
things.
example.
Yeah, it's simple things, and they make a culture of the company.
Yeah.
Because you know it needs to be promoted on all levels, really.
In terms of more, if we so going from these general values to more engineering principles. So what I would like to touch maybe a little bit is, and to give a context to listeners. So finance engineering and this finance team has probably a lot to do with regulators and compliance. And I'm sure you as engineers, you need to have a certain mindset to probably need to think about risk controls and auditing, immutability, whatnot. And there is a certain level of mindset in terms of also dealing with such highly critical software. I came, by the way, previously I worked in Better Medicine, which is a medical tech software. So you do AI cancer diagnostics, and again, regulations are very heavy. And you as engineer, you need to have a certain mindset. Yes, you need to be super agile and move fast, but you need to know when you're dealing with critical software, you apply as professional, like you're in your best ability and conscience, the important set of practices to develop high quality software, right? Like testing, other things, verification, pair programming, whatever you have in your team. But you act as professional and you understand this is critical because you deal with critical software. Same when people launch, other people on a rocket and, they know they can die. But I wonder in this regard, when stakes are high, what principles do you need to follow? And you expect your team to follow?
Yeah, it's actually there's nothing too special if you think about this. It's about testing, being very mindful about your code reviews, understanding the system scalability and performance, understanding the importance of the things that you deal with. I think if you get all these very standard things, you can apply them to any domain. I mean, obviously, there is different kind of shifts in some areas where you work with. If you work with finance, with the auditors, then you understand that, yes, there need to be controls and this kind of stuff. But in my idealistic view of the world, that should be applicable to any sort of domain that you work with. And in my experience, I had the chance to work a lot with auditors, so especially about at the time when Wise got to be the public company, I was very involved with the auditing team from Deloitte, who we work with to go through all our systems that we have, how we make sure that we're compliant with all the standards.
And those were also technical teams, actually, technical people who went over your services and asked questions.
That's quite interesting because also, like when if you think about this, when you're a small company, then the audit scrutiny and attention to you is not as high as you're a public company, or even like not
For
public
sure.
but very large size of company on whom people rely and trust their money to.
Absolutely.
So it's
just to give listeners a taste, like a idea, a ballpark of how much money Wise moves in 1 month or year. Can you give a ballpark? Money.
So Wise holds almost 13 billion pounds.
13
billions of customers' money, which is quite a bit.
13 billion of pounds.
Yeah.
This is on balances, right?
Balances, investment, kind of funds in custody, kind of, sort of. And then we have, I think the last numbers, and I hope I wouldn't lie here, but was about roughly 120 billions pounds yearly.
Can you repeat this number?
120 billions.
120 billions per year. Per year, and that's transfers.
Yeah.
International
kind
transfers.
Of moving money.
Yeah, this is just to give a scale of the amount of responsibility you have. And
that's a lot. And then kind of coming back to this point is, yes, I had to work a lot with auditors. needed to understand what they actually need, what they are looking for in that level of the company, who people can trust, who can be the public company, who can be very, who can disclose their statements, who can disclose their, upsides and downsides, and that led me to learn a bit from how to see the work of the company from a different perspective, from someone like who comes outside, what they look for, and I mean, and that's coming back to what I said, caring about things. So from, I've did myself a degree in finance. I've hold 2 degrees, one in mechanical engineering, one in finance. I've been taking the courses in, financials, and I, read myself all these financial standards and stuff. It's just, which is what really led you to be the professional in what you're doing, to just understand what's the problem you work with.
Understand the domain.
Understand the domain, exactly. Yeah, and then it's very, I think it's whenever you have this opportunity to work with some domain, you need to learn it very details. In my experience working with customer due diligence, I read Australian regulation about how the customer due diligence should work, UK regulations, so all this kind of large books and stuff. That's it's important. And if you do it well, then you kind of can succeed as a professional in your area.
That's true. Yeah, I mean, in Pactum we have another domain of autonomous negotiations, and we deal with some use cases such as procurement. And now I find myself, I want to learn more about procurement and how it works at all. And and it's important for the job. For engineers. I want to say that first of all, I agree with this. What you said, it's sometimes very simple. Well, all things in engineering are kind of simple, but we sometimes don't follow it, right? Or, but you mentioned things like testing, code reviews, scalability, performance. If you talk about the first point of testing, I'm sure you have your own philosophy of testing in finance engineering in your teams. You mentioned it to me briefly outside of current podcast that you do some bespoke testing approaches. Would you like to mention something about that?
Yeah, so it's kind of that bespoke testing approach was something that I come up with on my weekends.
Oh, cool.
And this is something for what my lead that days, Bogdan, was very angry about, me doing, because back days it looked very ugly. So the kind of the problem that we needed to solve was huge. So basically at the time we had many thousand lines of code with no tests, with 1,000 line methods, and the problem that you need to solve, how do you get what you have into the place where you have the microservice with a class interface, defined to all the things with quality standards in form of test, code coverage, being sure that things that you have not break. So there was a really big challenge of migrating, and moving from this point where you are now.
The big gap.
Yeah, to where you should be.
Yeah.
And I started questioning myself, how do we do it, making sure that things don't break. And what was very important as well is I think that the engineers, like software engineers, sometimes are over creative in the way how they do their work. And this is especially visible with the large code bases. You have so much of entropy and the ways how people do things. And early days I realized that I want to avoid this. So I was started thinking what's important to us as a kind of goal of what we are doing. And I realized that, okay, there is a very clear input, so you receive the product data, and then there is a very clear output. You are doing your ledger, the main accounting book.
So you can build a high-level test.
And then the other question that I had is, how do I give confidence to the people who I work with, who are not technical, who cannot go and read my Java unit test. And then I understood that I take this input and I provide the output on a high level, and it was in the form of people very familiar with in finance in Excel files. So I built a framework which is taking the inputs and kind of and outputs and running your kind of tests against it, like a contract.
Acceptance contract test.
Yeah, like a kind of.
High-level behavioral
like a
test.
high-level behavior test, which with one flavor in Excel, and it evolved a lot into the something where we have right now the cucumber tests, which are following very clear structure. You have the input data, and here's your output data, and over many years, I reinforced in thinking that it was a right approach. That now we have thousands of these tests. And they all look the same, and you can read them. You can those obviously the integration test, like higher level test, and that's how we assured that quality. So we understood that at that point in time when we needed to do migration, we do this high level test, testing inputs, how they materialize into outputs, and we applied this to all our migrations, and that's where we evolved. And over this like 7 years, it's where the system moved.
I actually so happy that you mentioned it, because I think it touches on a very deep topic actually. How do you, given a legacy system, right, and the fact that you want to move away from it, what are your next gradual steps? Because you have to kind of deal with the fact that yes, your system is not tested, and changing code is scary, right? So what is your first level of tests you add to kind of give your first level of safety net, but it's which still kind of the best bang for the buck, right? The best impact for the cost. And you mentioned, yes, this given clear inputs, you have clear outputs, so this high level test. I had a similar experience, and this is, by the way, what I read in the kind of, let's say, good books actually written by professionals who say the same thing. When you, I'll maybe share a not like personal story, but when I worked in one company, we had a legacy service which had no tests, and it was you could imagine like simple service with some API surface layer surface area. So there were some APIs called by other services, and it had very clear inputs to APIs and outputs, and no tests. And we did the same approach. So there were 0 tests first, but we needed the first layer of kind of this very good safety net. And what we did, we built API level tests where the test case looked like this, like given this API input, this is the output I expect. And then it exercised the whole, well, code base, right? Including the database. So we were not mocking the database, but using the containerized Postgres. And it was amazing. It worked well, and it gave us this first level of confidence to give us the confidence to refactor and change things inside the service, because you already have this confidence. And then later, of course, once you have better seams already inside the code, you can start adding whatever makes sense, unit tests, integration tests, etc. But yeah, this first point and adding this high-level tests, I think, is really important. And,
this is very valid. I mean, that's what we followed. One big challenge that we observed is how do you account for branching in your code, because it's very natural for people to build testing suites around the happy path scenarios. So what I was doing myself in past is if I understand that there is a high complexity business logic, I would not rely on myself identifying those branches and writing the test for them. So what I will do, for example, I'll take real data from production system. Obviously, like PII stuff, it's out of the question. But you will take the real data, and then you will run it versus your code. With the legacy system, you will understand what are outputs, and then you will basically do the same versus your new system. And you make sure that you have a 100% passing rate in terms of those outputs. Because it's very easy to introduce 1-2 tests and think, okay, like I'm safe here. But in reality, if you deal with a complex business logic, then you are not safe. You need to have this more like higher level, even higher level than the integration test inside of the class.
This is such an important point, yes, because all the branches will be executed only if you have large enough kind of sample which represents the production data. And of course, well, those branches that were never executed, maybe they're dead code and they should be deleted. It's also one question. But I want to recap it. So you run the real data, and let's say it's not even kind of a testing, it's almost like a script, right? Or you first run real data, you see the outputs, then you what? My question is, will you then use this real data in test suite later on and run it all the time, or
no? It
how
might
do you
be
convert?
like more like a regression. So you would get it until the point they understand this like 100% match. So then you kind of understand what are those scenarios that are failing.
Okay.
And those that are failing, you obviously understand that you need to write it as an integration test. So kind of you run it, you start from some pass rate, maybe like 50%, assume that 50%. And you understand that, okay, like this 50% is now covered by my logic, but that other 50 is not covered. So what do? You add your kind of test scenarios on top of it, which are like now integration tests, which will be run each time for your build process.
Okay.
And then you cover more logic, you get into your 100% pass rate, and you clear this point that your new system is doing the same as your old system.
I know in some systems, I mean, our companies having real data in automated test setup even is critically important. I'll give an example: Starship. Starship, well, the robotic software is super complicated, and they have a suite of tests where they have, and it's like the whole, it's kind of the whole company effort to have highly curated data, and it's the whole pipeline how real world data eventually ends up as a high quality data for testing purposes. And I think Tesla has the same problem, right? Where they build their neural networks and they need to constantly, learn from it and test, and they have regression tests, and it's constantly is the pipeline of the real data. And here, I realize it's a different flavor of it, but again, it pinpoints the importance of leveraging the real data to kind of find regressions and have more confident test suite eventually.
One thing that I will warn is that I do not believe in production database being obfuscated and put into staging.
Oh, let's talk about it. Yes, it's an interesting point.
It just doesn't work really. I mean, it works until some time, but then it stops when you reach the certain level of scale.
Yeah. What are alternatives? I'm just curious.
You need to introduce very conscious synthetic data generation if you care about this.
Yes.
With this production data obfuscated and moved to staging, there's a technical scalability challenges. There is a whole data privacy challenges, data security challenges, like data infiltration. So it's just in my experience, it didn't work.
I agree, and we have tackled the same we had to gripe with the same problem in Pactum. And we did discuss this production obfuscation to staging. It's super hard and it has a lot of problems with it. And I agree that having synthetic data is better, but you have to care about it as a team. Like it should be almost like as a first-class citizen. And anytime your product changes or anything, well, and this comes back to the topic of testing. If you care about testing, well, then you will care about synthetic data because you will care it to be as good as possible. But it requires effort, right?
Yeah, it's a hard problem.
It requires effort, but it's important. So you have it, right? You have a high-quality synthetic data in finance?
So we do put a lot of efforts into automated tests. I'm not a believer in a staging environment, since the logical dilemma I will have to people who would offer me the staging environment is especially valid if you're dealing with services in isolation. I mean, if you do have like your company flow tested in staging and you as a company committed to support this, then this is a separate story. But when people tell me about releasing something into staging which doesn't have the clear user interface that you interact, then I will very much question the value of releasing it into staging.
why, if we can
what
have
you will
automated tests.
what you will do when you will release it, what you will observe, what's kind of expectation.
And if you even if you observe it,
Yeah.
for me the main question is always why. By the way, I think we're on the same page, and I'm skeptical about generally about manual testing or relying on it too much.
Yeah.
Is that how will you make sure you catch regressions in the future? Because now you just tied yourself to checking it perpetually all the time
Exactly.
for all the time in the future. And if you don't do it, well, you can introduce regressions, right? And you will be more afraid to change the code in the future,
Yeah.
because you have no automated test to catch a regression. So for me,
Yeah.
honestly, this is the main downside.
Yeah, exactly.
Is
And then
inability
like
to catch
you
regressions.
release it there into staging, and what do? So you look into it, like you need to provide some inputs, and then like if you're looking for some specific outputs from your inputs, then why wouldn't you just do it as a integration test?
I found one value in staging sometimes. It depends, but I want to hear your thoughts. And maybe it's not as much related or as relevant for the platform team, but mostly for maybe those who build product features or especially user interface related. Sometimes it's useful, again, you can do it in different ways, but one way how we did it, again, staging or sandbox, but let's say you have a PM, a product manager in your team, and you do want to quickly, you implement something and you don't yet want to release to production, but you want them to check it out, to play around. This is kind of where I see the value of those environments to have.
Yeah. I mean, I agree that when you do have the clear way to interact with what you're doing, then it makes sense. That
But for
it
testing
value.
per se or
like
regressions.
But then like when you kind of trying to just kind of you as an engineer releasing something to staging to go and check something, I mean there are certain things that very hard to catch, like if you do change the like authentication, if you change the like endpoint security mapping and stuff, then it might make sense to release it in staging and test it there. Still like possible to do through integration test, but there's a case by case decision as well, but we need to be pragmatic about the staging as a panacea for all problems.
Yeah. Cool. I want to ask you one question about maybe for listeners. You're amazing engineer. You're a principal engineer in Wise, and it means a lot. And I'm sure you have something to say to listeners. In a sense, what would be your advice to progress as an engineer, to grow as an engineer? Because you did grow as an engineer a lot, and maybe you can give some advice even.
Yeah, no, I mean, as I said, my value is not in being the best possible computer science specialist, in the sense. I mean, I do know a lot about some parts of the systems, and in some areas I have expertise. But everyone would need to find their own path. And as I said, like if you care about things that you do, then it's not a question really how to grow. You care about things, you do it to the best extent that you can, and then you will see yourself growing as well. And it will very much depend on how that path would look. If you have some role model, someone you wanna kind of associate yourself with, then it's easier in some sense, because you look at someone, you understand that okay, they have certain strengths. I'm keen to have the same strengths.
So in a sense, surround yourself with people who you aspire to.
Either surround or find those people who you wanna be associated with, right? Who to whom you wanna level yourself up. And then that's really the path. And as an engineer, you might find yourself growing more into like a technical expertise. You might get very good into some specific kind of parts of the system, of the technologies. You might be more like a generalist. You might have very strong product skills. It will be very different for everyone, I guess.
Yeah.
So don't have like much of wisdom advice or something, but just more about caring about things and doing whatever you can to the best extent.
Maybe to reflect on what you said is that it's important for anyone, especially once in a while, like maybe at least half a year, to reflect on your own career and ask yourself a question honestly, like how has it been and where do I want to go from here? Like where do I want to grow? Do I have the right environment? And yeah, exactly, what's the path or journey I want to kind of continue from there?
Yeah.
So to kind of move more away from this kind of just sporadic, just being, into more like at least reflecting on,
it's
on,
about
on your
being
own.
intentional about what you're doing. It's not like kind of random atom moving in a space and continuum, right? It's about yourself knowing what you're doing, what you're looking for.
Yeah. But any, let's say, books or resources that you would say are generally like sensible things in your opinion to read, or what affected you a lot that you would recommend for sure?
I mean, there's like obviously there are good books, but I find like it's interesting because the different things would resonate with the different people. So someone would find inspiration in like non-fictional literature. Someone would read like like Engineering Manager Pat's book, right? And they find resonating to them. So I don't want to give a specific advice, right? Because it's to me the professional growth is not a checklist, really. It's about finding what would work for you, and it's very hard to say because I mean there is some technical literature, right? If I will tell you, okay, go and read about high performance GPA, right? The book that you mentioned in the beginning, kind of would it make value for you?
It depends.
It depends, right? You might get to know more about the database and transactions. I might suggest you go and read clean code, right? But then if you do not associate yourself with the situation, or you do not understand like how does relate to your work, then it might be irrelevant. There's a brilliant book which was advised to me by some other principal engineer in Wise about kind of performance and optimizations, and I understand that for different people who will read it, it will mean different things. If you do not comprehend what it's about, how do I apply it in my real life, then like what's the value?
I agree. In a way, how I think about it is that at different career stages, you will have different problems for which you want to seek answers. And of course, well, book or it's just one means to reflect and get some answers or some wisdom from people. And at that time, it makes sense to read good books on the class of problems that you're dealing with now, so you can reflect on it. So actually right now, even like I wanted to read, in fact, I bought this book, I don't know if you heard about it, Accelerate. It's kind of a famous book about, like building teams and continuous delivery, and the importance of software engineering practices to the throughput of the team, and all the science behind it. Like, so pretty much, I think the LDR of this book is that you cannot move faster by building, crappy software. You have to move fast. You need to build a high quality software with a high quality, in a sense, a team and team principles. So that's maybe TLDR. But I wanted to grab this book because I heard good reviews, and maybe even I know everything that is written there. But it will help me to reflect on what I know, and maybe I'll learn something new. But I grabbed this book because it's just a set of problems I'm solving right now.
Yeah, exactly.
And as you said, exactly, and you have more chance to get the value out of the book if you relate to the problems that the book addresses, or any resource.
Because in my early days of career, I cared a lot about technical problems, about like hard technical problems. How do you solve them? About the databases, about microservices, microservice architecture patterns, all that kind of things. Then like when I kind of switched to the leadership role, I mean the people questions is what I cared a lot. And then you kind of these days I do care about the interacting with the business, like how do you communicate with people, how do you deliver the solution, or how do you collaborate on the problem. So it's kind of very... I'm
reading one on this, by the way. It's called, maybe, I'm paraphrasing, I'm not remember. I just started to listen to this book. It's called maybe Having Crucial Conversations
Yeah,
or
it's
something
a
like
brilliant book. Yeah.
that. Yeah, that's and I started exactly to read it because, well, again, I related to the problem
Yeah,
of this,
yeah.
and then I was like, I'm gonna read that.
Yeah, and then it's important because then you kind of from the same book that you mentioned,
Yeah.
right? There's the idea about kind of shared pool of thoughts where you
Yeah.
encourage people to contribute,
Yeah.
and then by doing this you enable innovation because you can
Mhm.
kind of collide with people, and
Mhm.
they need to be not afraid to kind of communicate.
Have psychological safety to,
Yeah, exactly.
to
I mean,
express opinion.
but then like if you're, you know, if I'll get this book, you know, 10 years ago,
Yeah, you wouldn't relate.
I mean, I cared about like, you know,
JPA.
yeah, like, or I cared about the shaders in my GPU, right?
Yeah,
How do
yeah.
I visualize triangles on the screen, right?
Yeah.
This is what I cared.
Yeah, well, I would say it was quite a sound and wise advice. Thank you, Dmitry. I don't know if you want to mention something more or you want to say something to the
No,
end.
I think I enjoyed the conversation. Thanks for inviting me.
Same. Thank you, Dmitry. And I hope to talk to you more. Maybe we will have more rounds later.
Yeah, thank you.
Right, thanks.
Thank you.
Yeah.